Fanola 687 AU, 1957–1958. This is the documentation of the experience of a hobby project, available in video and in written form, made with the hope that it could be helpful to others. But any comment that could help me to improve my practice is welcome and appreciated. This radio was built during the years 1957–1958 by FIMI at Sarano Varese, Italy. An advert found in a magazine published in 1961 shows a model that is similar to this radio. There are a few variants of this radio with the model number 687, but also significant differences in the schematics. This radio model was capable of receiving the broadcast band, some shortwave FM, and some television audio channels. However, today, due to the changes in the transmission technology, that analog television band is useless. Being a radio that can receive such different bands, the switching system between bands and modulation is quite complex, making the interpretation of the schematic diagram and servicing the radio a demanding task. Luckily, this radio uses a printed circuit board, which at least reduces the troubles when the servicing is not related to the high-frequency modules. The radio is still capable of working, and only the replacement of questionable components that are easily reachable is planned. As already mentioned, this radio model has different variants, each with significant differences in the schematic diagram. Even if the goal is only to replace some components, the schematic diagram is necessary in case it were impossible to read the value that they are supposed to have. This is the original schematic diagram available online, with a few additional annotations based on the experience on the item examined in this project. The original schematic diagram reports the expected voltages between those points and the chassis, showing two different values. The upper values are meant to be found if FM or TV is selected, while the lower values are referred to medium wave or short wave. Please notice that the selection of FM or TV activates the same group of switches in the main switching module, and only a remote group of switches makes the difference in the two selections. One can see that pressing the TV button pulls the remote switch under the VHF or UHF section of the chassis. However, the TV band has two sub-bands, high and low, and one of them must be preselected from under the chassis. One thing that should be checked with tube radios made in the 1950s and in the 1960s is the possible deterioration of capacitors inside the IF transformers. That would be called silver mica disease. In this radio, the IF transformers are easily inspectable, removing a couple of screws under the printed circuit. Luckily, these IF transformers use regular coated capacitors, for which there is no reason for concern. While under the chassis, the printed circuit is relatively clean. The top of the printed circuit with all the components is covered by dust and grease. It is necessary to clean that coat of dirt, and some alcohol is used for the purpose. However, most of the resistors appear to lose their color code with alcohol or any other mild detergent. Even though the value of most resistors is still in tolerance, as they have discolored, or they are going to discolor while cleaning, all the reachable resistors will be replaced. The cleaning process will progress slowly while changing the components. Printed circuits are always delicate in relation to the applied heat necessary for soldering. While the soldering process is relatively easy and fast, usually desoldering requires more effort and more attention to avoid ruining the copper traces. It is probably better to cut the component that is to be replaced, remove the old tin with a desoldering braid, push the terminals out, freeing the holes. The new component could then be installed very easily. This boring clip, which now is just slightly accelerated, shows the process for the replacement of a single component. This radio uses a selenium rectifier made by Siemens. This is replaced with a silicon diode FR207. While replacing the selenium rectifier, also a resistor could be added to maintain the voltage differential and control current surges. However, in this case, a different solution is used, which will be described later. It is unclear the function of the capacitor in parallel with the rectifier. Maybe it is meaningful only for that type of selenium rectifier. Anyhow, this component, which is also clearly destroyed, is replaced with a safety capacitor. The original schematic diagram mentions that this should be a polyester type. But the real original one seems to be only a paper capacitor. While testing, using an isolation transformer and a dim bulb, the radio shows that it is able to function properly at just about 160 volts AC instead of 220, when the filaments would receive only around 4.5 volts. As this reduced filament voltage would increase the life of the vacuum tubes, instead of the resistor replacing the differential voltage of a selenium rectifier, a small light bulb is integrated in the radio with the function of current regulator. Consequently, all voltages that would be found in the radio circuit might be lower than what annotated in the original schematic diagram. This video clip shows what happens when the radio is turned on with this integrated light bulb. Another important adaptation is related to the antenna input for medium and short wave reception. The original schematic diagram only considers the possibility of a wire antenna. While it is important to be able to connect a loop antenna, which would also require a connection to the chassis ground. The chassis ground is connected to the mains. Therefore, two decoupling safety capacitors are needed. While cleaning and working on the printed circuit board, the trimmer R37 might be disturbed. Its function is to balance the detection of the frequency modulated signal. It should be adjusted to obtain the right quality of sound while receiving FM stations. At the beginning of the refurbishing process, the dial cord is still operational, even though it is a little loose. While working around the chassis, the dial cord becomes looser and trying to tighten it breaks. So it is necessary to study the dial cord arrangement, which appears to be unusual and interesting. The dial cord is not anchored to the variable capacitor drum, only the tension of the spring keeps it in place. Some thick fishing wire is used with success. The mechanism that is used to distinguish between the selection of TV or FM can become problematic. After the first restoration of this item, the radio remained unused for about 1 year. Then, while testing it again, the TV and FM switches had the tendency to remain stuck. It was necessary to remove the original steel cord and replace it with something else. Here some strong fishing wire was used, luckily with a good result. The cabinet has two things to be taken care of. One foot is detached and the bottom shield, made of aluminum foil, should be replaced. First, the aluminum foil is removed. In fact, it was originally a sheet of paper with aluminum foil glued on top of it. The same thing is reproduced with a thick sheet of paper, glue, and aluminum foil. Before proceeding with it, the detached foot is checked. Originally it was attached to the cabinet, melting a portion of the plasticate in the corresponding cabinet hole. The foot is attached again with a small screw. It is important to consider that that screw might get in touch with the aluminum foil inside the cabinet, which in turns would be connected to the chassis. This means that the foot screw must be insulated after installing the foot again. In this case, it will be covered with hot glue later. The sheet of paper and aluminum foil is then cut to the needed size and glued inside the bottom of the cabinet, paying attention to avoiding the risk of electrocution. In particular, it should not be reachable from outside the cabinet, neither directly nor indirectly touching metal objects that are exposed from outside. For example, at the bottom of the cabinet there is a metal plate that is used to cover a hole which would allow access to the TV sub-bands selection. The screws holding the plate to the cabinet will be replaced with nylon equivalents to make sure that there will be no contact with the internal aluminum foil. This radio, like others produced in particular in the 1950s in Europe, by design has some safety issues that no type of restoration could solve, which normally one would not think about. The most important thing to take care of and to keep in mind is the risk of electrocution. The radio chassis, and consequently all metal parts contained in the radio, are connected directly to the mains. Even when the radio is turned off, but still connected to the mains, getting in touch with any metal part of the radio would imply an electrocution. The typical dangerous situation that could happen is that a knob comes off and one might be tempted to put it back on the metal shaft. However, if the radio is still plugged to the wall socket and the shaft is touched during this maneuver, one would be electrocuted. For the same reason, operating the radio with wet hands might be dangerous. If the water gets in touch with the volume or tuning shaft, the operator would be electrocuted. For reducing the risks of electrocution caused by a live chassis, the chassis should be at the same potential or close to the neutral line. Therefore, the power switch should be moved on the hot line, like in this new additional adaptation. This way, the chassis would be connected to the neutral line, regardless of the fact that the radio is turned on or off. However, this radio will be used in an environment where the power outlets are not polarized, therefore one could not predict which is the right orientation. In order to show if the power plug is inserted in the wrong way, a simple adaptation could be prepared. In this example, the supposed neutral line is connected to an LED to ground, so that the LED becomes very bright if, instead of being connected to the neutral, it is instead on the hot line. In other words, the LED would become very bright if the plug is inserted in the wrong way. However, this solution cannot prevent mistakes nor failures. If the external ground is not available, the LED would remain always dark, or always lit if there are other losses. But even the LED may suffer from a failure, remaining always dark. Therefore, one should test both orientations, verifying that the LED becomes bright only in one way, choosing then the orientation in which it remains dark, or simply not too bright. What you see and hear is a reception test done in the early evening with an indoor loop antenna connected via coaxial cable to the new antenna port added. Please notice that at the time of this test, the dial indicator was attached to the wrong side of the dial cord, moving in the opposite direction of what it should. This mistake would be corrected later.
La dolce vita, volevo fare.
Cresimo, monastero
Primario.
The test starts with the FM band, which for this radio is between 85 and 102 megahertz.
cercavo di fabbrica.
The test continues with the medium wave band between 530 and 1570 kilohertz, about 570 and 190 meters. This band is mostly affected by electrical noise produced in the whole neighborhood.
Fiamme anche in Grecia, i grandi roghi nel.
Shortwave band between 6 and 11 megahertz, about 51 and 28 meters.
セカンドアルバム「天の守護神」からシングルカットされ
There is nothing that could be received in the television band. This video comes with written documentation available from the links appearing in the description under the Show More tab. One may find files corresponding to individual chapters with the topics of interest, or a large single file with the whole work, which however is updated less frequently. The written documentation is meant to support the videos with updates, references, more detailed and better resolution pictures. The written documentation also covers annotations regarding failed projects and other stuff that doesn't have a corresponding video.